Good day guys, welcome to Brain Balance tutorial. We'll be discussing colligative properties, and there are some things that you need to understand before we can proceed to colligative properties itself. The first key point is that there are some physical properties of some solution that used to be different from those of the pure solvents. That is, let's take an example. Pure water usually freezes at 0 degrees Celsius, right? When you add a salt to the particular water, changing it to an aqueous solution, it tends to say that what? It will freeze at a lower temperature. What does this mean? That means that what? The salt being added to the water changes it to an aqueous solution, which tends to reduce even the freezing of the water solution. That is why your ocean during winter, you will see at the surface it gets blocks, but underneath you can still see that what? There is a liquid roaming about. It doesn't get freezed up totally because of the salt quantity. The third thing is that many solutions, they used to depend on the chemical identity of that solute, which is true. It is the help of the solute that used to determine the kind of solution we could call a particular combination of the solutes and the solvent. Let's assume you have a solution of hydrogen chloride. We could call it acidic. A solution of NaCl, now we could say it is an aqueous solution when it is mixed with water. Also, they used to depend on the total concentration of the solute. Like I said now, when you keep adding much more solutes, it keeps decreasing in the temperature. That's for freezing point, it decreases more. Now, like I said now, it also depends on the total concentration of the solutes. Even they don't care about the identity. Let's say you have sodium chloride and you have potassium bromide. As you can see, they don't care about the sodium chloride or potassium bromide. There's something important in them that they need rather than their identities, because sodium chloride and potassium bromide can have the same amount and even the same stage of lowering in temperature. How? Follow me on, we'll understand that better. Now look at the next point. It says that ethylene glycol, you see, ethylene glycol, we all know it is called antifreeze. Why is it called antifreeze? Because when it is added to radiators of car, it acts as an antifreeze to lower that freezing point more of that solution, so that the waters won't get freezed up totally, and in order to enable the engine to run very well. And if you are to look at this now, it can also raise the boiling point of the solution. Also, when the water is not freeze at a particular point, in no time when the engine starts up, the water would also helps in regulating the engine very faster to operate the engine at higher temperature, making it to run very well. Now, what do we call colligative property? Colligative means depending on the collection. Colligative means depending on collection of something. Like we said, that the solution depends on the amount of quantity being added into it. So therefore, colligative properties depends on the collective effect of the number of the solute particles. So what are the properties? The properties is that the first thing, they are physical properties of solution. That is, they are physical properties of a solution. Number two is that they depends on number of solute particles in a solution, which we have just said. The third is that they do not depend on the type or nature of solute particles. We would come back to this number 3. And let's say you have a pure water, like I had said, boiling at 100 degrees Celsius. If you add the salt to it, the salt will increase the boiling point of the solution. That means that what? It will be greater than 100 degrees Celsius. So therefore, the boiling point increases as the what? As the solute particle increases. And since that happens, we could say that what? The boiling point elevation is a colligative properties. In the next slide, we would be explaining Van 't Hoff's and also the categories of the colloidal properties, which is the vapor pressure lowering, boiling point elevation, freezing point depression, osmotic pressure. Thank you. Please like and subscribe.